Today we're going to talk about trigonometric equations. So let's start with an example. In this example 1, we have a rabbit population in a national park that rises and falls each year. In January, the population is at its minimum of 5,000 rabbits. And in July, when the weather is warm and food is abundant, the population has tripled in size. Okay, so 1,500, right? 3 times 5,000. By the following January, the population has again fallen to 5,000 rabbits, completing the annual cycle. Okay, so our first task here is just to sketch a graph. And we're going to assume a sinusoidal function for the rabbit population. So let's take the information that we got from the problem statement. So, well, and I should say too that we're going to set t equals 0 to be the beginning of January. So January, the month of January is actually maybe I should scroll down a little bit here. There, we can see this graph a little bit more. So this is actually January. The duration of January is between 0 to 1. Okay, because it says that at the end of December it's by the end of December to beginning of January, the population is 5,000. So let's put a point there. 5,000 rabbits going into January. Okay, and then let's go ahead and mark actually across the bottom so we know what month we're working in. So if that's January, then this is February. This is March, April, May, June, July, August, September, October, November, and December. Okay. And yeah, we could actually mark that point too. At the end of December, going to the next January, we're back down at 5,000. And by July, the rabbit population has doubled. So I'm going to say that's going into July because that's right in the middle here. So that's the easiest place to put it. So going into July, end of June, going into July, we're at our maximum population of 15,000 rabbits. Okay. So just with those points, I can see that halfway between 5,000 and 15,000 is 10,000. So that's going to be our midline. So I'm going to put a dash line across here to mark the midline of our sinusoidal function. Okay. All right, so that's our midline. So actually, I'll just write off to the side here that midline is y equals 10,000. All right. And, all right, so if we're assuming a sinusoidal function, so that means halfway between the minimum and the maximum, which is going to be here at 3, we're going to cross the midline, right? In the same way here, another 3 months out, at 9, we're going to cross the midline. Okay, so now we have some points that we can connect and draw what this sinusoidal function is going to look like. Okay, so I'm going to try and draw this, make it look like a sinusoidal function. We'll see how neat it is. All right, well, so far so good. All right, come back down, and then we end up here. Okay. All right, so that's our sinusoidal function. Okay, we've got a midline of 10,000. Let's also write down here what the amplitude is. So the amplitude is the distance from the midline to the maximum or minimum. So from 10,000 to 15,000, that gives us an amplitude of 5,000. Okay. And because I can see, it says down here, find a possible formula for the rabbit population. It would probably also be helpful to have the period. We know the period of the function is 12, so 12 months, right? The period is 12. And the period is also 2 pi over b. So if we're going to write a possible formula, we need to have b. So if we solve for b, we end up with b is equal to 2 pi over 12, which happens to be pi over 6. All right, so I think now we have everything we need to write the function. So let me scroll down here just a little bit. And I want to write a function r, okay, as a function of t, okay. And so first of all, I want to look at what kind of shape is this? What sort of which sinusoidal function do I want to use? Sine or cosine? That's what I'm going to be limited to. That gives me the shape. Both sine and cosine have this sort of shape, but does it look more like a sine or a cosine function? So cosine usually starts up high, dips down, and comes back up. All right, sine starts at 0 and comes back like that. Okay, so this is cosine, and this is what a sine, just the normal sine function with, sine of x and cosine of x. Okay, so it looks to me like it's a cosine function, but it's flipped over, right? Because here we're starting down low and then going high and then coming back down low. So I'm going to say that it's a negative cosine function. And the amplitude is 5,000, so I'm going to write minus 5,000 cosine. Okay, and then I want b times t. So that's going to be pi over 6 t. And there's no horizontal shift here. It looks just like a cosine function flipped over. It's not shifted horizontally or anything. So we can just leave, we can close our parentheses, and then the midline is 10,000. So I'm going to add 10,000 to it. Okay, and there we've got a function for the rabbit population over time, t. Okay, and if you're not sure, you can always plug in some values. Like if I plug in 0, I should get 5,000, right? So cosine of 0 is 1, right? So when t is equal to 0, this term becomes minus 5,000 and then plus 10,000, which gives me the 5,000, right? If I put in 6, right, I get 6 pi over 6, which is just pi. Cosine of pi is minus 1, right? And so minus 1 times minus 5,000 is a positive 5,000, and then we add 10,000 and you get the 15,000. So just like you'd expect. So it's checking out. I feel confident now that my function is what I want it to be. Okay. Now, the next question asks to use the graph to estimate the time interval during which the rabbit population will be over 12,000 in one 12-month period. Okay, so we've got it graphed for one 12-month period. So we're just going to use the graph for this. I'm going to pick up a different color pen just so I can distinguish it from my green markings here. Let's see, maybe I will, maybe I'll get a red pen. Okay, there we go. All right, so close that. Okay, so 12,000 is, so this, you can see there's 11,000, 12,000, 13,000, 14,000, 15,000. Okay, so 12,000 is right here. Right here. So if we draw a little dotted line over, you can see there's one point where the graph is, where the y value is 12,000, and then we have another point over here. Okay, now obviously this is a sketch of a graph, and I didn't plot any points in detail, so these answers are going to be a little off. But let me go back to the green pen here. You can see that if we just estimate from the graph, it looks like about t equals 4. It looks like the rabbit population will be 12,000 from about t equals 4 to about t equals, and again, I can't really tell for sure. It's a little more than 8 the way I drew it, but I don't trust my sketch to be that accurate. So I'm just going to, it looks like the closest whole number is 8, so I'm just going to say 8. Okay, now if we want to interpret that, t equals 4 and t equals 8. So 4, if we're right at 4, that's the end of April, right? Beginning of May. So I'm just going to say from the end of April, okay, t equals 4, April, I can't spell, April, all right, to, all right, t equals 8, where t equals 8 is right in between August and September. So we're going to say the beginning of September. To the beginning of September. Okay. All right. So we've estimated using the graph. So the next thing we're going to do, come down here a little farther, and we're actually going to use the formula now to get a more accurate time when the population reaches 12,000. Okay, so what I'm going to do, I have my equation right there. I guess I'll leave it right here. All right, so I'm going to take my equation. I have minus 5,000 cosine of pi over 6t plus 10,000 is equal to 12,000, right? I want to find out when the equation gives me 12,000. Okay, so the first thing I can do is just subtract 10,000 from both sides. So I'm just going to rewrite this equation. Minus 5,000 cosine pi over 6t, okay, is equal to 2,000. Okay, and then I can divide both sides by 5,000. So I get cosine of pi over 6t is equal to negative 2/5. Okay, because I'm dividing by minus 5,000. All right, well, let's take a look at that. I want to find where cosine is negative 2/5. So I just want to find it. I need to do an inverse cosine. But again, I don't trust inverse cosine completely because it only gives me one answer. So I want to look at this and make sense out of it. So I'm just going to draw a unit circle. Okay, I love drawing unit circles. All right, circle. All right, so cosine is the cosine value of this 6 pi or pi over 6t is negative 2/5. Okay, so the cosine is negative, which means we're over here. So let's say this is about 2/5 in the negative direction. Okay, I can just draw a line straight up from there, and I can see that, let's see if I can draw my angle, that particular angle that intercepts here at that point would be one place where the cosine is negative 2/5. But I also have another one down here, right? Now if I do inverse cosine on my calculator, it's only going to give me the top one, right? Because cosine, the range of inverse cosine goes from 0 to pi. So I'm only going to get the top one, but I've also got another point down here that I have to make sure I account for, right? Because you could see from the graph we had two places where the graph went through 12,000. So we need to find both of those. All right, so if I take the cosine inverse, I'll just write it off to the side here, cosine inverse of negative 2/5. I'm just going to use my calculator. I am going to use radian mode, so my angle or my output here will be an angle in radians, okay? So if I do it in radians, I get a cosine inverse is 1.98231, okay? Which means, well, okay, so that's this angle right here. So now I need to figure out, let me kind of draw that here. So if that angle right here is 1.98231. It's probably more accuracy than I need. But, okay, so now we have to figure out where is this angle down here. They're going to have the same reference angle. But you can also see that I could just measure in this direction by negative 1.98231. Okay. Now I want my time to be positive because I'm not going to go back in time. So I want the positive version of that. So I'm going to take 2 pi and subtract 1.98231. And when I do that, I get, what do I get? 4.30088. Okay. All right, so we actually have 2 values. So down here, I'm going to say that pi over 6t is equal to 1.98231. Oops, that looks like a 7. Let me, not that it matters, it's kind of, I don't know how precise we can actually need to be here. I know I'm going overboard with precision here, but, all right. And the other answer will be 4.30088. Okay. All right, that's pi over 6 times t, but I actually want t, right? So t, if I divide both sides by pi over 6, I will get, what did I get? I got 3.786, and if I divide the other value, I get 8.214. Okay, so that's my time value. Now these time values correspond to months on the graph, right? So let's interpret that. Well, I guess we could kind of interpret it just the way we did. So it's about 3/4 of the way through April, and about a 1/5 of the way into September. So, but the way we've defined time, I guess we could just leave it as those values, if you understand how we numbered the months. Okay? All right. So the key to solving trigonometric equations is recognizing that you're going to get more than one value. And you need to use inverse cosine a lot of times to solve these equations, but keep in mind that it's only going to give you one of those values, one value, and you have to figure out what the rest of those values are. So let's take a look at the next example. Okay, we'll just stop there. All right, so let's take a look at this example. It's pretty straightforward. We're just trying to find where the sine of theta is 1/2. Okay, but we're asked to find where sine of theta is 1/2 between negative 2 pi and 6 pi. So, all right, let's take a look at a unit circle. You probably recognize the sine of 1/2. I always like to visualize it though. Okay. All right, so sine of 1/2 means that the distance above the x-axis is 1/2, right? So I could just come up like that, right? That's 1/2. And the angle that goes with it is here. And now as you guys are all experts at the unit circle, this happens when theta equals pi over 6. Okay. Now it also happens over here. There's a positive sine value over on this side as well, right? For this angle here, if this y value is 1/2, this angle also has a sine of positive 1/2. Okay, and this angle over here is just pi over 6 shy of pi. So this is the angle theta equals 5 pi over 6. All right, so we need to find all the angles between negative 2 pi and 6 pi though. These are just 2 of the angles. But all the rest of the angles are going to be coterminal, at least with respect, on the unit circle, the rest of the angles are going to be coterminal with either pi over 6 or 5 pi over 6. So we can just keep adding 2 pi and get another angle. Add another 2 pi, get another angle. We could subtract 2 pi because 2 pi is a full rotation, right? It's once around the circle. So we could subtract 2 pi and get another angle. Same way with 5 pi over 6. We could add 2 pi or we could subtract 2 pi and get more angles, right? So we need to find all of the angles between negative 2 pi and 6 pi that are coterminal with pi over 6 and 5 pi over 6. All right, so sometimes it helps to sort of visualize the graph too. Now, I don't think you necessarily have to do this on every problem, but just for illustration, because this is we're still learning at this point, and I want to make sure you understand what's going on. So if we were to graph this, let's see how well I can graph it. I graphed it in the notes, the completed notes that are on Canvas. So I don't know how they're much. It's going to be much neater because I'm using a pencil instead of this pen tool. But you can see that the period of sine is pi over 2. So if I want to go all the way to 6 pi, I'm going to have 3 cycles, right? I'm going to have 1, right? And then 2, it's going to be a little wobbly, and 3. Okay. So, this is going to be 2 pi and 4 pi, and this is going to be 6 pi. Okay. And if I go in the other direction, I'm going to have one more cycle. Ooh, like that. But these should all have the same amplitude, which they don't very well, but they're all going to go, it's just an amplitude of 1 and negative 1, right? This is going to be negative 2 pi. Okay, so that's what this is going to look like, and we're looking for where the sine of theta is 1/2. So I could kind of illustrate that's going to be these points right here. 1, 2, 3, 4, 5, 6, 7, 8, right? Yeah, 8. We've got 8 solutions. So we should expect 8 solutions, right? Because you could see that if we graph this function between negative 2 pi and 6 pi, it's going to cross y equals 1/2 8 times. Okay, so all right, let's go through that process. Now we already know 2 of the angles, right? We've got theta equals pi over 6, and then we got theta equals 5 pi over 6. This equals 5 pi over 6. Okay, so all we need to do, so basically we have this one. I'm going to draw a little line coming up, and we have this other one. And if I want to get the next one, that the corresponding point in the next cycle, all I need to do is just add 2 pi, right? And if I want to get this one, which is the corresponding angle in the third cycle, then I need to add 4 pi to go from here to here. And if I want to get this point here, I've got to subtract 2 pi. Okay? So you could also see that on the unit circle. So let's just do that. Let's take pi over 6 plus 2 pi. That's going to give us another angle that's coterminal. All right. Now 2 pi is the same as 12 pi over 6. So I'm just going to do that, and I get 13 pi over 6. Okay. I can also take pi over 6 and add 4 pi. Okay, so that's 24 pi over 6, which adds up to 25 pi over 6. And that gives me all the angles up to 6 pi. I need to go backwards, though, and get the one that's negative. So I get pi over 6 minus 2 pi. Okay, so minus 12 pi over 6 gives me a negative 11 pi over 6. Okay? So those are all of the angles that are coterminal with pi over 6. So I could even just circle those because these are all answers. Okay, those are all answers to this equation. All right, so I just need to do the same thing with 5 pi over 6. So 5 pi over 6 plus 2 pi. Okay, so I'm just adding 12 pi over 6, so I get 17 pi over 6. If I take 5 pi over 6 and add 4 pi, I get 29 pi over 6. And if I take 5 pi over 6 and I subtract 2 pi, then I get a minus 7 pi over 6. All right? And again, those are all going to be solutions. Okay, so there's all of my 8 solutions. I was expecting 8 solutions, and here they all are. I'll just circle them and say that's my answer. Okay? So it's kind of a lot of work, but it's just, take it one step at a time. You'll get it. Okay, so what if I want to, this is the same problem. What if I want to find all solutions? How can I write that? Now, really, I already solved the problem here. I know I'm just trying to find all the angles that are coterminal with pi over 6 and coterminal with 5 pi over 6. So the way we can write that is that I'll just write theta is equal to pi over 6 plus, I can just add multiples of 2 pi. I could do 2 pi or 4 pi or 6 pi or 8 pi. And I can also go the other way. I can subtract 2 pi or 4 pi or 6 pi or 8 pi. All right, so I'm going to write that as pi over 6 plus 2 pi n, where n is an integer. Okay, so I'm just going to write down here, where n is equal to, it can be equal to 0, plus or minus 1, plus or minus 2, and so on. It could be any integer. All right, but, okay, we got one more though. And theta is equal to 5 pi over 6 plus 2 pi n, right? Again, where n is an integer. And that's how I would write all the solutions, okay? It's just either 5 pi over 6 or pi over 6, and then I add any number of rotations and I get coterminal angles. All right. All right, now these are similar, but not quite. This next one says find all the solutions to sine of 3 theta equals 1/2. Okay, sine of 3 theta equals 1/2. So instead of theta, we got 3 theta. But we're going to have the same 3 theta is going to have the same angle. So if I do the inverse sine of 1/2, I'll get the pi over 6, and then I have to reason out just like I did before. The other coterminal, the other angle, it's going to be 5 pi over 6. Okay, so what I have is that instead of just theta, though, it's 3 theta. So 3 theta is equal to pi over 6 plus 2 pi n. All right, and, that's supposed to be an n, and 3 theta is equal to 5 pi over 6 plus 2 pi n. Okay? That's 3 theta, but we actually just want theta. So if we divide both sides by 3, I get theta is equal to pi over 18 plus 2 pi over 3n. All right, and the other one is going to be theta is equal to 5 pi over 18 plus 2 pi over 3n. Okay, so now I found all the solutions. And you can see now I'm adding 2/3 pi. And it makes sense because the period of sine 3 theta is 2 pi over 3, right? So in this case, our b is equal to 3, and the period, right, is equal to 2 pi over b, which is just going to be 2 pi over 3. So to add another period, we have to add 2 pi over 3 instead of 2 pi, because this function, sine of 3 theta, has a period of 2 pi over 3. Okay? And, all right, now this is again related here. Now, so it's actually easier to find all the solutions and express it in terms of n, which is just an integer. But if they ask you to find all the solutions in a certain range, here between 0 and 2 pi, then we just need to take our answer for all the solutions and then figure out which, what the specific angles are that are between 0 and 2 pi. So if we take a look at this one, here it's the same problem, sine of 3 theta equals 1/2, but now we want just the angles that are between 0 and 2 pi, not all of the angles. So let's take a look at what a graph of this looks like, just to get your head around it, so you can visualize it. So between 0 and 2 pi, because the period is 2 pi over 3, it's going to cycle. We're going to have 3 cycles between 0 and 2 pi. So if I wanted to graph this, I would graph 1 cycle, 2 cycles, 3 cycles. Okay, and then I get up to 2 pi. Okay, so you can see that we're going to end up with, if I draw, this is where sine of 3 theta equals 1/2, assuming that's y equals 1/2, then we're going to end up with 6 solutions. So we should expect 6 solutions, right? So this is y. All right. So we just need to substitute in some values for n. So this cycle, the first cycle here, is going to be n equals 0. The next cycle is just going to be 1 period forward, right? So this is going to be n equals 1, and this is for n equals 2. So what I can do, I'm just going to make a little table. I'll have my n values and then my theta values for each one of these angles. So I'm going to make just a little table here. Theta. Right. I'm just going to draw it like that. Okay, so I need n equals 1. When n equals 1, I can just read it right. Or sorry, n equals 0. I want to do n equals 0 first. Right? N equals 0. And then I can just read it right off. So it's pi over 18 and 5 pi over 18. Okay, I'm just looking back up at example 4 to figure it out. I'm just plugging in n equals 0. Okay, for n equals 1, I'm just going to add 2 pi over 3 to the pi over 18. Now that's 12 pi over 18. So I'm going to add 12 pi over 18. So it becomes 13 pi over 18. Okay. Same way over here, I'm going to add 12 pi over 18. So I end up with 17 pi over 18. All right, and then we can do n equal 2. So now I'm adding 4 pi over 3. Okay, 4 pi over 3, which is what, 24 pi over 18. So for n equal 2, I get 25 pi over 18, and I will get 29 pi over 18. Okay. So that's my answer right there. I put it in a table form just to make it a little easier, but that is the solution. It's all 6 of those angles satisfy that equation between 0 and 2 pi. Okay, so you can tell already this is going to be a long it's going to be a long one because I got another page here. All right, so let's keep going here. This is a little more complicated problem here. So now we have cosine of 2 pi times the quantity t minus 1 is equal to minus square root 2 over 2. Okay, and we want to find all the solutions between -3 and 9. Okay, well let's analyze this equation first. All right, now you can first of all just take a look at this. This is our b value, right? So that means that the period of this function is 2 pi over b, and b is pi over 2. So our period is 4. Okay, we can also see that we have a horizontal shift going on here, right? It's going to be shifted horizontally to the right by 1 unit. So horizontal shift equals, 1 to the right. Okay. So sometimes it's helpful to have a little picture, get your head around it, right? So I'm just going to sketch this, what this graph looks like. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I need to go 3 over this way. All right, so it's a cosine function. It's shifted to the right by 1. So we're going to start out here at 1 at at the top, right? If we're just graphing y equals cosine pi over 2 times the quantity t minus 1. Okay, so, and it has a period of 4, so we're going to go 2, 3, 4, so here's 5. All right, we're going to end up back at that same point, and then in the middle we're going to be at -1, and we're going to cross the axis here and here. Okay, so we can draw one cycle here just by oh boy. Okay, there's one cycle. It's hard to draw with this pen on the screen. All right, so there's one cycle of the cosine, and then it's just going to repeat from there. So another cycle will end here at 9 because the period is 4, right? And it'll do the same thing. It'll come down and cross here and end up back where it started. So let's see if I can draw that. Okay. All right, and then I could draw another cycle going the other way, and conveniently it ends up at -3. All right, so it's going to end up back here. It's going to cross here, and then so it'll go like that. Oops. Okay, so there's a graph of our function. And we're trying to find where this function is equal to a negative square root 2 over 2. So let's just kind of draw in a dotted line of where that is. So it looks like we're going to get 6 answers. We're going to get 6 values, okay, between -3 and 9. Now I'm also going to draw a unit circle, right? Because it's square root 2 over 2. That looks familiar, right? So let's figure out the angles where the cosine is negative square root 2 over 2. Okay, so negative square root 2 over 2, that looks like it has a reference angle of 45 degrees, but it's in either the second quadrant or the third quadrant where cosine is negative. Okay, so I need the x value to be negative, right? This distance right here, which is the cosine, has to be negative. Okay, so I end up with angles there and there, which have the negative cosine. Okay, and we could use an inverse cosine, but if we want exact answers, I mean, we could tell this is going to be 3 pi over 4, and this is going to be 5 pi over 4. Okay, so, all right, now we know this whole thing that we're taking a cosine of has to be either 3 pi over 4 or 5 pi over 4 or some angle that's coterminal with those, right? So the thing that we're taking a cosine of is pi over 2 times t minus 1. And that has to be either 3 pi over 4 plus 2 pi n, okay? Or pi over 2 times t minus 1 is equal to 5 pi over 4 plus 2 pi n, okay? Now we just need to solve for t. We're trying to find all the solutions. We'll try to find all the solutions first, and then we'll plug in values for n. So like this is going to be n equals 0, and this is going to be n equals 1, and this is going to be n equals minus 1. All right, so let's do that. Let's divide both sides by pi over 2. So then I get t minus 1 is equal to 3 halves plus 4n. All those pi's cancel. And we'll have t is equal to 2.5, right, as a dense decimal, plus 4n. Okay, I'm just adding 1 to both sides to 4n. Okay, so we'll do the same thing over here. We get t minus 1 equals 5 halves plus 4n. And then that means that t is equal to, adding 1 to both sides, I get 3.5 plus 4n. Okay? So if I want to make a little table of n and the theta values, okay, for each of those angles, theta, theta, so n equals minus 1, 0, and 1. So at n equals minus 1, okay, I'm going to, just plugging in n equals minus 1 into both of these equations, I get an angle of minus 1.5 and minus 0.5. If I plug in 0, I get 2.5 and 3.5. If I plug in 1, I get 6.5 and 7.5. Okay, so this is essentially my answer. This right here is my answer. I get a table of all of those. I guess it's not theta, is it? It's t. So I should probably erase these and make it t. These are my t values. Okay. So let's keep going. All right, here's one where we're solving for cosine. Cosine of theta equals negative 0.75 between negative 2 pi and 4 pi. Okay. Now this one, you know, it's not an angle, this is not going to give us an angle that's a nice 30 or 60 or 45 or some other angle with that reference angle. You know, if you look at 0.75, you don't recognize that as something that we've been drawing on the unit circle. So we just have to use our calculator. So that's why I wanted to show you this one. So this one, we can use the cosine inverse. The inverse cosine of negative 0.75. You plug that into your calculator, and what you're going to get is 2.4189 radians. I'm using radians because, you know, these, if it doesn't say degrees, it's radians. And a lot of the stuff we're going to do is radians. So unless it specifically says degrees, then assume that it's radians. All right, so let's take a look at, again, I like to draw unit circles. So there's a lopsided circle, but I'm looking for where the cosine is negative 0.75. So if we go over the x direction by negative 0.75 and then go either up or down. Now my circle is really lopsided, so this isn't going to look this isn't going to look great. But we're going to have a couple angles here, here, and here. We have to find out where those are. All right, so we already know that, you know, cosine inverse is going to give us an angle between 0 and pi. So we know that this angle is 2.4189 radians. And I can find this angle just by subtracting, it's either negative 2.4189, or I can take 2 pi and subtract 2.4189 to get this other angle here. So if I do that, I get 3.8643. All right. So once I have that, then, that's the only place where the cosine is going to be a negative 0.75. Okay. So all I want to do is find angles that are coterminal with those. So I'm going to get theta is equal to 2.4189 plus any number of rotations, 2 pi n. And I have this other angle, 3.8643. Again, I could just add any number of rotations. So if I want the values between negative 2 pi and 4 pi, I just need to add n number of rotations to either one of these angles. Now, again, I don't know that you need to draw it out, but sometimes I'd like to draw it out. It's a cosine function, so it's going to, here's one cycle, right? That brings me to 2 pi. 2 pi. I go another cycle. Oops. Right there. Brings me to 4 pi. Okay. And if I go backwards by a cycle, that brings me to negative 2 pi. All right. So I want where the cosine is equal to negative 0.75. So if I drew a line through here, you can see that we would expect 6 solutions. Okay. So that's going to be n equals 0, n equals 1, and this is going to be n equals negative 1. All right, so let's make a little table here. Negative 1, oops, actually, I'm going to set up a header for the table first. So I'm going to have n, oops, pick up the pen, n, and my 2 theta values. So -1, 0, and 1. For -1, I got -3.8. I'm just going to say 3.86, rounding it off. All right, and this one is going to be -2.42 if I round it to 2 digits. I don't really know how precise I need to be. N equals 0 is just 2.42 and 3.86. And for n equals 1, I get 8.70 and 10.15. Okay, so there's my answer. Those are all the angles between negative 2 pi and 4 pi. All right. Now, I think this is the last one before the practice problems. So, but there's other types of problems, other than just solving for one. Sometimes you have equations that involve multiple trig functions. And there's a practice problem that's coming up that I want you to try that's very similar to things I saw on tests. So this is another one where we just need to, this is an equation and we need to rearrange it and solve for tangent so that we can solve for theta, right? So if I just subtract 5 tangent of theta from both sides, I'll end up with, on this side, 2 tangent theta. And if I add 1 to both sides, I get -2 on this side. So that's basically telling me that tangent of theta equals -1. Okay, where is tangent -1? I can draw this unit circle. My really lopsided unit circle. It's going to be -1 over here and over here. This is 3 pi over 4. This down here is either negative pi over 4 or we could make it 7 pi over 4. Okay? If we're going just in the positive direction. Now, tangent has a period of pi. So really, you can see these are just pi apart. So I could really just write my answer as theta is equal to 3 pi over 4 plus pi n, right? Not 2 pi n, pi n, because the period of tangent is pi. And you can see that that will capture both of these angles. Okay, so now I just need to find all the n values. So if I do n and theta, right? So for n equals 0, and I'm going 0 to 2 pi, so at 0 I get 3 pi over 4, and at 1 I get 7 pi over 4, and that's it. That's all I need because I'm only going up to 2 pi. Okay, so two periods of tangent. All right, so I'm up to 50 minutes already. So you can pause the video, look at these practice problems, and then come back and view the solutions if you need to. Of course, the solutions will be posted on Canvas as well, so you can just check your answers, and then if you need to view the video to understand it and understand any of these better, you can do that. All right, so let's keep going through these practice problems. All right, so here's the first practice problem. This is very similar to one of the ones we just did. We're going to use our calculator to calculate the cosine inverse of 0.3. Okay, that gives us a number in radians, 1.2661. Okay, that's one answer, right? It's the answer that's between 0 and pi. But if we look at it on the unit circle, you can see there's other angles that have a cosine of 0.3. Let's say that this is 0.3 right here. If we go straight up, there's an angle. That is our 1.2661 radians. But there's also going to be another angle down here. Now this is supposed to be perpendicular here, but we'll also have another angle down here. All right, so this angle, if we go all the way to here, is 1.2661 radians. And then we can go the other way, minus 1.2661 radians. Now if I want the positive version, because I'm interested in angles between 0 and 4 pi, so I can find the positive version of that angle by subtracting 1.2661 from 2 pi. That gives me 5.0171. Okay, so that's the first two positive angles. All right, so in general, our solution is going to be 1.2661 plus 2 pi n, right? And the other one, which is 5.0171 plus 2 pi n. Okay, so if we look at, let's just make a little table here, our theta values for n equals 0 and n equals 1, I get, when n equals 0, I get 1.2661 and 5.0171. If we add 2 pi to those numbers, we get 7.5493 and 11.3003. Okay, so there's our solution for the first practice problem. All right, let's take a look at the second practice problem. Here we're asked to find all solutions for the equation below for theta between 0 and 4 pi. Again, 0 and 4 pi. All right, so this one we have a 2 times sine of 2 theta. Now, if we just divide both sides by 2, we get sine of 2 theta, or 2t, I guess it is equal to square root 3 over 2. Okay. Now, if we look at that on the unit circle, we can find some values where the sine is square root 3 over 2. Right? So square root 3 over 2 is that distance above the x-axis, right? Because the sine is the y value, the distance above the x-axis. All right, so there's one angle right there, and we know that that's pi over 3. And there's another one that has a positive square root 3 over 2 over here, like that. And that one is 2 pi over 3. Okay? All right, so those are the values where sine is equal to square root 3 over 2. But it's 2t. 2t equals pi over 3. And any angle that's coterminal with that, so we have to add 2 pi n. We also need this equation because 2t could also equal 2 pi over 3 plus 2 pi n. So now we have to divide by 2. You get t equals pi over 6 plus pi n. And if we divide this one by 2, we get t equals 2 pi over 6. I'll just write it as 2 pi over 6, even though that's pi over 3, right? Or maybe I'll just write it as pi over 3. Let's write it as pi over 3. All right. So pi over 3 plus pi n, dividing out both sides by 2. All right. All right, so now we need all of the solutions between 0 and 4 pi. Now, this is a a horizontal compression, right? It's going to increase. So instead of cycling once in 2 pi, it's going to cycle, the period is pi, right? It's going to cycle twice over 2 pi. And you can tell that by, from down here too, that, the period, you're just adding a period every time. So, if we were to sketch that, if I just did that quickly, you're going to get between 0 and 4 pi, you're going to get 2 cycles will bring us to 2 pi, right? And then another 2 cycles will bring us to 4 pi, right? So then that's 4 pi. Okay, and we're looking for all the values, where the square root 3 over 2 is positive, positive square root 3 over 2. The sine of theta is, or sine of 2t is positive square root 3 over 2. Okay, so we should expect like 8, 8 solutions. All right, so let's list some of these out. So I'm going to write n, and then both of our theta values and all of the angles that are coterminal with those. Okay, so at 0, we've just got pi over 6 and pi over 3. And then we want 0, 1, 2, 3, and that's it, right? Because this is going to be n equals 0, n equals 1, 2, and 3. All right, so when we do that, I'll just list it out here. 7 pi over 6 and 4 pi over 3, right? I'm just adding pi to either pi over 6 or pi over 3. If I add 2 pi, I get 13 pi over 6 and 7 pi over 3. If I add 3 pi, I will get 19 pi over 6 and 10 pi over 3. Okay, so there is my solution. All right. One more problem here. Okay. Now, this is one that I saw on some of the old tests that I was looking at. So, there's a number of problems like this. Now, whenever you see something where you have 2 factors and equal to 0, we can use the zero product rule, right? The zero product rule just says that if you have 2 factors multiplied together and they're equal 0, then either one of the 2 factors have to be 0. So we can solve this just by saying, well, okay, either the factor tangent theta equals 0, or the factor 2 sine theta minus 1 equals 0. Okay, if we solve both of those equations, both of those factors for 0, we'll get all of the solutions. All right, and then we want the solutions between 0 and 4 pi. So here, if I solve it in general, tangent is equal to 0 at 0 plus pi n, right? Because the period of tangent is pi, right? Over here, I had to add 1 to both sides and then divide by 2. So I get sine theta equals 1/2. So again, I can look at my unit circle, figure out where is sine theta equal to 1/2. So I can make 1/2 up, 1/2 up, right? So I got a couple of different angles, all right? So here I can say that theta is equal to pi over 3 plus 2 pi n, and 2 pi over 3 plus 2 pi n. All right, so now I just can use n and you know, until I get to 4 pi. So I'm just going to list them out. Instead of putting them in the table, I'm just going to list them out here. So I get, if I just take the first equation where tangent theta equals 0, I get 0 and pi and 2 pi and 3 pi and 4 pi, right? Those are all of the angles between 0 and 4 pi that satisfy tangent theta equals 0. And then I'll just do the same thing for the next equation too. So n equals 0, I get pi over 3 when I substitute 0 here. If I substitute 0 over here, I get 2 pi over 3. Okay, now let's do n equal 1. So I have pi over 3 plus 6 pi over 3, which gives me 7 pi over 3. Okay, so that angle is going to be coterminal with the pi over 3, just one rotation forward. And then I'm going to have 2 pi over 3 plus 2 pi n. So 8 pi over 3. Okay, now that takes me to, let's see, is that all of them? Is that all of them? I'm just looking at my solution. That's all I listed in my written solution here. But I just want to make sure, because that's 2 2/3. So do I need another one? If I could just add another, you know, 2 pi, and I can see it already that would take me too far, right? If I add another 2 pi to either one of these, it's going to take me over 4 pi, right? Because this is already 2 1/3 pi and 2 2/3 pi. If I add 2 pi to it, that's going to be over 4 pi. So that's it. That's all I need. That's my solution right here. All right, there you go.